Cook from Accenture here to tell us about finding, using, and shaping Pan-Canadian fire standards. Sheridan Cook is a manager with Accenture Consulting that specialises in helping provincial and federal agencies translate their requirements for data exchange into fire implementation guides. She worked on many of the guides she'll discuss today: Pan-Canadian Patient Summary, Canadian Fire Exchange Specification, CA Baseline, and CA Core. And she's passionate about building the communities that contribute to the collaborative standards development's life cycle. So it's a pleasure to meet you, Sheridan. Can't believe it's the first time that I've met you after all these years. And thank you so much for joining us. I will pass the screen over to you.
Linda, let me get screen sharing up. All right. You folks should be, oops, I'm a little ahead. You get a sneak peek of what we're about to talk about. All right. Can you guys see? I've got presentation mode up for
That's
the
perfect.
beautiful. All right. Welcome, folks. Welcome to Finding, Using, and Shaping Pan-Canadian Fire Standards. Colloquially, we've been dubbing this Bases, Cores, and Mores. So my goal for today, I'm going to cover a number of different topics, but my real goal is to get you excited about the standards philosophy and why we do the work that we do, and to try to give you this kind of 10,000-foot view of the landscape of what's available in terms of baseline and core and international specifications in this space, and ultimately try to convince you to not just use what's available, but to be part of the community that is developing these specifications. So it's a lofty goal, but hopefully we can get there with some of you. Like Linda mentioned, I think the thing that is more interesting that isn't mentioned on the screen, and I'm reflecting on what Samir had mentioned, which is how do I get started in fire as a student? And what's not mentioned in my introductory page is that 8 years ago, I was a Master's of Social Work student who had no computer science background, had a liberal arts degree, and got pulled into an internship where they asked me to create realistic looking patients. And it was as simple as what Lloyd had mentioned, looking at examples of what does patient data look like in fire and what does it look like in HSMV2, that really kind of sparked this interest. And so what I like to tell people is that if me, little old me, who's a master's of social work, very social science oriented, can become involved, understand the specifications, and ultimately be part of this community, there is a space for everyone in it. So Samir, I love the question that you asked, and I really hope that you folks, what you pull from this today is that everything I'm about to talk about, like there's no barrier of entry there, and our goal is to try to engage you to actually be part of this community. So really excited to come back to UVic and to talk to our latest and greatest growing stars. But anyway, the real intent, I think, today is to try to kind of convince you of some of the reasons why we don't use fire straight out of the box when we go to develop. So many of you, I think, have probably, at least via Lloyd taking you there in the last session, seen HL7.fire or HL7.org/fire. And I will ask for a little audience participation. How many of you guys, if you can just put your hand up, have seen or interacted with the Canadian Fire Registry on Simplifier? Is that something that's new to many folks? I see hands going up. Fabulous. Love to see it. Okay, good. That helps me gauge a little bit on, how much exposure you guys have to some of the resources about where we host the specifications that ultimately utilize and promote standardization in fire. So, why don't we use fire out of the box? Or why do we not try to utilize it out of the box if we have resources available to us? I like to say that fire is a platform standard, which effectively means that we're given kind of building blocks in the base specification. And so fire provides us with resources that allow for us to describe concepts in healthcare, right? And it gives us the syntax and the language and the structure for how to do so. But the intent of the international spec has been and always will be built to be flexible, right? To support a vast range of use cases and regions and various levels of implementation design. And that's really its underlying intent, right? To be agnostic to so many of those choices and to be flexible enough to support them. And as implementers, we're given these kind of building blocks to piece together and parse together in ways where we can apply our additional constraints and we can effectively put them together to meet our own requirements. So that, and I'll use this analogy quite a bit, but if you want to build a house or a barn or a stadium, no matter how you want to pick those bricks and put them together, fire will give you at least the underlying materials to do that, and to build the structure that you need. Now, just because you have access to those bricks doesn't mean the work is done. And I think maybe that's one of the assumptions that we try to quash right off the bat, at least in the standards space. Because, as a base specification, fire is going to show us, how do I model this concept, right? But the thing that drives interoperability, the ability for us to see this kind of ubiquitousness and this ability for data to be exchanged between partners seamlessly, regardless of kind of the context under which the implementation occurs. The thing that drives that interoperability is something called profiling. So profiling effectively allows for us as authors, profile authors, to put restrictions on how elements within a resource maybe are populated or not populated. That's something we call cardinality. They let us set rules about our servers and what kind of API features they support. One of the really common aspects of profiling and the constraints that gets applied is in terminology. So it might say, for this particular element, you have to utilize something from this SNOMED value set. The cool thing about profiles is that they allow us to also put kind of additional context. So they might provide additional guidance on, how do I understand this element in the context of this implementation? So in my analogy, where if you have fire and the resources are your building blocks or your bricks, I like to describe profiles kind of like blueprints, right? They're a building plan. It's how do you put those bricks together to accomplish your means? And if you think about that analogy a little bit further, your implementation guide is the thing that houses those blueprints, and it provides guidance on how do you use the space that you're going to build, right? So each implementer is intended to build a implementation guide, and that implementation guide is going to define how they utilize those blocks to meet their needs. I think the trick that we often miss with, I think, this blueprint analogy and with profiles is that just because you have the ability to draft up a blueprint doesn't mean that if you're doing that in a windowless room and you are trying to create this cohesive space with others, that when you put each other's blueprints together, it's going to form this habitable space, right? So the example I sometimes will give is, if you want to say, bring a bunch of people together and say, we want to create a mall, and you tell one group to go off and build, or I should say, go off and design the food court, and another group of folks to go off and design a first floor bathroom, and another group to build a second floor bathroom. What you'll find is when they come back together and they layer their blueprints on top of each other, the pieces aren't going to fit, right? And I think that the piece here is that when you try to build the mishmash components of these blueprints, what you're going to find out is that you need a bunch of kind of custom sizes of materials and a bunch of really unique and niche skills. And all those things are going to lead to costly implementations of your ultimate blueprint. And in some cases, when you try to piece these things together, it might actually be dangerous, right? Or it might prevent the use of a space as it's intended entirely. And so, I think of, if you're drawing out the analogy even further, the beautiful thing that we have here in Canada, which is national building standards, right? Because if we want to build them all in Canada, we have things that allow us to say walls should be built with 2x6 boards, and all the toilets need to be 30 inches from the wall. And when we start to see some of those underlying national standards in place, we start to see some of those problems with fit and complexity start to at least resolve. Maybe not entirely, but we start to at least see some removal of the customization that's required. So if fire is your bricks and your profiles are your blueprints, national standards in the pan-Canadian space are your building code, right? They aren't going to tell you this is exactly how you design your room, but they are going to give you a lot more efficiencies in the process. They're going to streamline the process for your builders. They're going to make your materials cheaper, and they're going to make it easier for everybody to get out of this what they put in, because everybody's going to be using the same sizes for things in, in the underlying analogy. So if that analogy doesn't stick for you guys, I'll give you a more practical example. So you can see on the screen, I've got just a really simple pattern for ways that EHRs might implement FHIR, right? So you might implement a FHIR server over your underlying database, right? That serves up your clinical information in the FHIR resource format. You might have that information be then accessible via FHIR API. So in our example, if you are working at a hospital and it's trying to make its data available through an API that's connected to the FHIR server, and you've decided as a business analyst or a clinical informaticist to map date of diagnosis in your EMR to the FHIR resource element on condition called recorded date. But across town, somebody else maps it to condition onset time. Something bad happens, right? And that the really biggest areas of impact to us having a mismatch in where we're applying those mappings are going to be the first an EMR system APIs. And that's because ultimately APIs are effectively rule bases for how do you interact with this information, right? And if an EMR like Epic or Cerner serves multiple sites and locations, and those multiple sites and locations map to different elements in the FHIR standard, that is a line of code ultimately that has to change, which means hours of development, it means database refactoring, a bunch of QA, and all of this being done over across multiple environments. And the question I often get when we are actually working with FHIR implementations with folks, especially when there's a desire to kind of customize and extend, is who's going to pay for it and what falls down off the list that gets deprioritized because of this specific difference in how I want to map this field. What is the thing that is critical to our clinicians that they aren't going to have this quarter or this year because of that additional kind of discrepancy? Now, I think the other thing is that was the example I provided you if you're working with an Epic or a Cerner or a TELUS, some EMR that's going to serve multiple sites in your region. But even if it's a different EMR system that's ultimately serving that location that has a different mapping than you did, that is going to create a problem in a different space, which is actually in the application space. So this thing is that applications, right, particularly ones that connect to clinical data sources, really just want good data and they want predictability. They want to know what is it going to look like and how should I ask for it? And they want to be able to pre-configure that so that they can bring that to multiple places. And I think it's the things that people get really, really excited about when they're talking about clinical applications is that they want to focus on how do I provide actionable insights? How do I deliver on value? How do I provide clinicians or patients with another way to interact with their information in a way that's going to improve their care? But in order to do that, you need to be able to collect a lot of data and you've got to be able to deploy at scale. And ultimately, you've got to keep the lights on so that you can deliver value. And so if an application, something that you've got on your iPhone, has to go to Hospital X and configure to request their data one way, and then has to tweak their code a little bit when they go to Hospital Y, that means that they're going to spend all their time onboarding and tweaking their code, when what they really want to be able to do is to put out a single app and ensure that it's designed in such a way that it works in a bunch of different places. So on the screen here, I've got kind of examples of app galleries, particularly ones that work on Smart on FHIR, that really lean into this concept. But if we are as implementers and folks that are actually doing some of the mapping to FHIR in our places of work, also not adhering to standards, we're creating a challenge that actually prevents them from achieving kind of meaningful impact in their space. So hopefully you guys are convinced a little bit about there is maybe some challenges to just picking up the base FHIR spec and having a go if there are things that are available to you to try to standardize around. And the answer is yes, there are actually. So in Canada, we have a number of pan-Canadian standards that help address this problem, that provide for more consistencies across regions and use cases for how folks are implementing FHIR. So I like this view. It's a little bit hard, I think, at first to kind of conceptualize, but the primary premise for this is that uh, when you go to implement FHIR, there's actually a bunch of different layers of specifications that you're typically interacting with, regardless of whether or not you're aware of all of them. Most of the time in countries with more developed and mature ecosystems for FHIR implementation guides, you are going to see at least 3 or 4 of these levels. So you've got the FHIR base specification, which is the thing that is supposed to be global. It's use case agnostic. And we think of this as a kind of an inverted triangle around constraints. So the more surface area in this triangle it takes up, the more constraints and restrictions that are getting applied, the more specific definitions and implementation patterns that are going to be provided. So when we look at the FHIR base specification as like the bottom of this pyramid, while it's really, really broad and it's global, the actual constraints on how you utilize it are very small. Then we get up to like the next layer that we will see in many countries that have established FHIR ecosystems, which is like our national base or our baseline. This introduces kind of the next level of constraints. Oftentimes it's primarily to describe like realm concepts. So things like, what does our national identifier look like? When you send a telephone number, what are the supporting sub-elements that should come with it? Minimal constraints that ideally are really realm specific and that provide countrywide consistency, right? But these things they tend to be more reflective of the realities of Canadian healthcare and its delivery rather than necessarily constraints for a specific use case. The next layer up in our inverted triangle is that national core. And so that's where we start to see often more strict requirements for systems to align to. And still, I think I would say a broader set of use cases it's intended to support. So oftentimes we'll see cores that say, we're intending to support the exchange of information in FHIR to support patient access, for example, or the exchange for acute care. Really kind of much broader spaces, but more prescriptive requirements that allow for us to create more predictability in what someone who has a FHIR server implemented in Canada is going to be able to support by default. Now, the next layer up, and I would say it's a much more substantial jump in terms of actual volume of constraints, are use case domain guides. So this would be like a specification that has a focus like, let's say, patient summary. And the idea is these are the constraints that are specific to patient summary. They really don't care about what's going on in the US or Canada, but it is what are the things that we need to convey and contextualize, and what are the rules that we need for the types of resources and the elements within those resources to create and exchange patient summaries. Now, the last piece, and I actually would say we're starting to see, I would say, more and more proliferation of these, at least in the Canadian FHIR registry, is more implementation level implementation guides, which basically just says, the way I would convey this is a guide that's supposed to define the rules for how you interact with a specific asset. So if you are talking about interacting with like OLIS to perform a particular function, those are the types of kind of rules that we would expect at this implementation layer. Like, what is the security protocol for this client registry that is based out of BC, right? It's typically like to the asset, to the specific tool that the guide is being written for. Oftentimes we see these more at the provincial level because provinces are defining ways to integrate with those provincial assets in FHIR more frequently than, specific health systems are. And so ultimately, I want to be able to have you guys be comfortable and aware that there is this kind of fabric at play, and that ultimately the intent is for these specifications to actually work together to promote harmonization and to promote kind of the right rules in the right places, so that we can see those kind of maybe economies of scale for some of these constraints across across our nation. So, like I said, it's a fabric or a landscape of standards. So you guys have heard now that FHIR is flexible. And there is a reason for that, right? Because it has to be flexible enough to solve a variety of different problems in a variety of different ways. The challenge is that our impact or our choices ultimately impact how systems get designed, right? And the higher up that these deviations occur, kind of in this kind of pathway, right? The more likely they are to result in dramatic impacts to design. And so supporting more and more, I would say, pathways is going to be more likely to have more and more challenges to interoperability, particularly the earlier in the journey that you are. Now, the closer you get to implementation, oftentimes that's when we see actually more choices that you're typically given. But regardless of whether or not we deviate early on or closer to implementation, the idea is that if we take too many pathways, there's a lot more diversity in the way that our systems are designed, and it puts a lot more burden on them to be able, or I should say, it puts a lot more burden on like applications and clients to have to figure out how to interact with many, many different systems that are designed different ways. And so I think it's kind of our inherent responsibility to be really, really thoughtful about, how am I putting forward and making choices in the paths that are available in my space? How can I reduce differences and customizations when they really aren't absolutely necessary so that I can reduce that burden for the systems that really want to be able to connect to my information in consistent ways and not necessarily have to spend their time customizing around my particular pathway that I've designed. So standards are a way that when used together, provide this kind of slimming of the paths forward, right? So I like to say that international standards and national standards and and regional standards, these programs kind of all need each other as part of an underlying continuum. So it's kind of natural for these things to work together because they allow for us to have kind of collective documentation of our shared requirements. And ultimately, they allow us to do things like, remove choices that don't make sense in certain contexts. They help lighten the load through things like collective bargaining. So a really cool example, at least in the international level, that I like to talk about is 2 years ago, both Norway and Canada were both looking at, how might I explore particularly how e-referrals are delivered in Canada through shared vendors like Epic. That is a really common EMR vendor that both is shared in Commonwealth countries as well as in the US. But the way that we deliver care in Canada and the way that care is delivered in Norway differ slightly differ slightly from the US in how e-referrals are done. But they have actually some similarities to each other compared to the States. So the idea is that if Canada and Norway can work together on an international specification for e-referrals, we're actually kind of participating in this collective bargaining concept where it's a lot easier for us to get EMRs like Epic and Cerner to move down this path with us and implement the standard if there's actually a significant number of nations that are doing it this way, right? Because Epic doesn't want to have to similarly have roads paved for many different system designs. So effectively, we all work better together when we have some of this coalescence occurring at the international level and then at the national level and eventually at that regional level as well. I love my analogies. Like I said, I am a humanity focused background, and I find it to be one of the more interesting things about standards is like how to draw parallels to standardization in the real world. And so I like this map parallel as well, because I think the idea is that international and national and regional or provincial standards really work well together, similar to the map system when the idea is our layers are aligned. They're kind of saying the same thing. They're not introducing conflicting statements. but also they work best when each layer performs its particular function. So, a map of us, the entire kind of Australian coast isn't expected to zoom in and provide the specific highways to one of its states, right? And it's really important that those functions aren't overlapping or contradicting. So that a highway in one particular map isn't actually charted differently in another. And so when we're working both in the international and the national and the provincial spaces on developing standards, we have to be really, really careful to stay in sync with each other to ensure that we are performing each function properly and that we aren't conflicting with each other. And there's a lot of work that's going on in the background that I think maybe often isn't immediately clear until you're part of the community of what that harmonization effort actually looks like. So let's say you're kind of bought in. Sounds cool. Standards make sense, at least on like a philosophical level. Then you might be wondering, how do we do it? And so the next section is really focused on how do we get Pan-Canadian specifications built and how do we change something from like a specification into a standard. So my goal here is to really just kind of remove the mystery of what happens in our working groups as part of standards development to make you feel more comfortable and confident that this is a process that you can join in and that you don't have to be an expert in this to participate. So how do Pan-Canadian specifications get developed? The underlying answer is people. So people, often people are coming together who are passionate about a particular problem. They form something that I think Lloyd dubbed, or at least uses pretty commonly, called the coalition of the willing. And the idea is that if I go off in a windowless room and I say, it should work this way, I'm going to design something that I'm going to make this recommendation, and that's what people should do. That's not a standard. And unfortunately, a lot of people do design implementation guides and specifications that way. When it becomes a standard is when enough people have had their eyes on it, they've contributed to it thoroughly, they've assessed how does this work in my own environment, they've provided feedback so that it gets refined, and they really have provided this kind of thorough buy-in that this is going to work and this is going to be stable for my environment. And the way that that doesn't devolve into total chaos is that ultimately we use a standard process to actually promote this specifications onto things that have gone through the process of building trust and having enough cycles where folks ultimately then can really feel comfortable utilizing it in a normative way. And that process ultimately happens under a structure often that we use called the working group. So working groups are effectively just a governance structure that determines, how do we make decisions about a particular specification? How do we behave? How do we vote on something? How do we document our findings and our rationales for why we made certain choices and certain changes? And that these working groups, when they deploy this process consistently over time and produce it, or I should say, support this process in such a way that it's predictable, that creates maturity of our content, and it does build trust and stability and ultimately desire for reuse of the product that the working group makes. So consistent process is what allows for outputs of the working group to gain that level of trust and adoption that I think it's kind of like drives ultimately the thing that turns specs into standards. And that overall kind of process is what we call the collaborative standards development lifecycle. So the CSDLC for folks that are not necessarily in the know. And we call it a life cycle because it is a repeatable process that is focused around this continuous improvement and maintenance of the thing that has these kind of known on-ramps and off-ramps. So the example I'll show here in a minute is like an off-ramp for release for publication. So if we're talking about these working groups, right? Those are the core of development and maintenance cycle. So typically a working group will, and one that's active, that's been kind of ongoing and working in a space, will basically have meetings sometimes weekly, bi-weekly. They'll have a set of topics that they want to discuss for potential changes to the specification. Now, They will often have a very, I would say, formalized way of kind of making decisions and documenting ultimately, yes, we have consensus to approve a change in the spec in this way. But the end kind of outcome is that ultimately the changes that get approved and decision through the working group get applied to the spec. Now, oftentimes when they're getting applied in this kind of development lifecycle, they're getting applied to something we call the continuous integration build. We borrow that from the software community, but effectively it just means the latest and greatest as we make changes, no promises until we put this into a formal release because things could still change. And at some point in time, after making a number of these changes and having these discussions around what should maybe get added or enhanced or refined in a implementation guide, the group comes together and they assess readiness for release. And this could be at any number of levels. It could be a release that is to fix a bug. It could be a release for something minor, like a clarification that was deemed necessary based on feedback. Be something major, like a totally new workflow. But ultimately, that decision of are we ready to move forward to publish something is a key kind of point within this life cycle. The next step up is that specification release, which ultimately creates that first on-ramp out to publication. So often when we have a publication of an implementation guide, we will categorize it in different ways. So we say, oh, it's this version, 1.1.0. We'll also oftentimes apply like a type, a definition to say, is this draft? Is this trial implementation? How do I clarify its maturity to someone who's reading this and trying to determine, is this ready for me to implement? And then oftentimes there's also kind of a release type. So that would be like, is this something you are explicitly asking me to provide feedback on in the form of a ballot? And at this point in time of this release publication, that can either go straight to, okay, now we're ready to test this, or even put this out for conformance. Do beta testing, ask implementers to do trial implementation, put it forward for like projectathon or conformance events, or even put it into a conformance tool for assessment. Regardless of whether or not we go from publication to testing, or straight onto feedback, no matter what, there's always the cycle, even coming out of testing, that leads back to the kind of last stage of the life cycle, which is the feedback process. So the feedback process is effectively, it gathers whatever the outcomes and the findings were from the ballot. So things like, I think that must support on condition onset time is too strong because implementations may have XYZ reason for not supporting it. Things like those types of feedback that ultimately lead to the working group receiving it and making choices about whether or not they make that change in the spec. Testing events provide us a really, really critical input into the feedback process as well, because they allow for us to say, oh, we're noticing a significant trend in these number or types of vendors that really can't meet this requirement or that interpreted it differently. And so we look at feedback in a kind of much more comprehensive way in that sense, where it's not just, did somebody tell me to change something, but it's also where are the stumbling blocks that we're seeing consistently occur. And sometimes it's after a specification has been implemented, it's actually implementers coming and saying, I went to go develop this and I found out that like that terminology value set you defined doesn't expand the way that you think it does. And I got a different outcome when I actually went to go validate this in my own implementation. So all of these are kind of natural and common places where we are receiving feedback for an implementation guide that ultimately all feedback into the working group. So it truly is this, while it looks a little more complex, it's this one big cycle that is ultimately driven by feedback and really predictable processes for decision making and application of those decisions. So I wanted to give you an example of one of the Pan Canadian specifications that kind of followed this process, and just explicit examples of where we hit certain stages. The slide that I'm showing here first is mostly about how a new specification actually ends up kind of forming, and like what the initial stages are kind of end to end for what aspects of the implementation guide we build, like sequentially, I should say. So whenever we find there's this group that's kind of starting to be engaged around a particular topic or a pain point, there's discussion maybe on our national forums, there's polls to basically assess, is there a need for specification? Do we need standardization in the space? Sometimes provincial agencies are polled to say, where are the places that you're planning on going next that you would like to have a little bit more standardization with each other on? Regardless of how the forming stage starts, typically when a working group is at least first considered, there's an environmental scan to basically say, what's already out there in this space? Is there something that we can lift directly from either a national or international landscape? Or is there something that we can potentially lift and extend, like in our case, international patient summary or mobile care services discovery, that we think we want to be able to push folks towards utilizing these patterns, but we also have maybe additional Canadian requirements we want to extend on top of that. So there's always this step to ensure like we're eating our own dog food and actually going out and looking out in the world. Has this been solved before? And seeing, can we solve the same problem by applying the same requirements? At that point in time, where you've kind of, the initial homework is done, you've got a coalition of the willing. Typically, one of the first things that the working group will do is they will try to define the scope. What makes up this implementation guide's boundaries, and what should be the first set of use cases that we want to work on, right? From the perspective of a release, we need to have tangible, tangible boundaries of what can be accomplished in a period of time that will help us prioritize and develop requirements around. And often at this time, we also, at least in the Canadian space, we try to utilize a structure that comes from HIE, where at the time of basically saying, well, it's these sets of use cases, we also try to identify like actors and roles. So what are the types of systems that we are going to set expectations for, and the types of interaction patterns that we would expect them to adhere to. This third stage is the requirement stage. That's, you've got your use cases, really when the working group starts saying, okay, what are the requirements based off those use cases? And it's great when we can lift, especially a starting set of cases and requirements from an international guide. And ultimately, our goal is really just to document those business and technical requirements and align them against those actors and transactions. Oftentimes at the stage, what we'll do is also, especially if it's the first time a spec is being developed, we will define collectively a definition for must support. This is always one of the hardest parts in a working group because must support is such a flexible concept. Thank God we are working towards more structured conformance expectations through obligations, but many of us still use must support, and it's really important that you get consensus, and also you try to actually have harmonization in how others are defining must support as well. If nothing else, ensuring that you have clarity on exactly what you mean when you put that flag next to one of the elements in a profile. This next stage is technical design. So this would be where, okay, so you've got your use cases, you've got your resources, initial requirements for those. You've got your initial requirements. Then you want to be able to say, these are the specific fire resources that I would actually expect to be targeting my workflow. This is where I'm going to start thinking about applying constraints to those resources in a profile. And I'm also going to be thinking about exchange. How is this resource going to be exchanged, and creating integration patterns and sequence diagrams as needed. One of the great things about doing the working groups through that, like we have in Canada, that are often hosted by our secretariat, Canada Health InfoWay, is that like a lot of this stuff is patterned, right? And has actually a lot of support from like coordinators that are used to doing documentation in this format. And so when we come to the working groups and we are able to just participate from the perspective of, I think that as an implementer, this is how it would work in my scenario, that there's a lot of support to actually kind of probe that and massage that into kind of these patterns that ultimately help us support the documentation. The last piece, which is kind of like a maybe an oddball grouping, it's basically we're trying to further define standard ways for how to exchange the content. So at this phase, we might start to create capability statements. We start to say, these are our expectations for search parameters. So I like to do this after we've defined the actual kind of profile requirements, because it allows for us to basically say, how are you going to retrieve them, right? And what should your server be designed to actually accommodate? It's also our chance to try to kind of apply the HIT standards processes to gather feedback about the artifacts. So oftentimes there's like an initial round after you've created your profiles, your capability statements, your documentation and your implementation guide for kind of rapid rounds of feedback, sometimes even through balloting processes. And then eventually the group will start to strategize after it's done a number of refinements on the guide. How do I want these requirements to be tested? We're starting to, in our Pan-Canadian working groups, work towards actually having testing requirements and test cases be part of what gets produced in terms of standard documentation. Like we're starting to move down that path. Many working groups, particularly at HO7, are starting to kind of utilize even the fire resource, I think, test case and test scenario. I have to go back and look at that. But they're starting to use standard fire resources to document these so that it's not necessarily like an afterthought. It's actually just a part of a work product that goes along with an implementation guide that a working group produces. And eventually, those things actually, those expectations get utilized when you go to test that specification to see if systems are actually meeting the requirements that you put forward at testing events like projectathons here in Canada. So this is just one example of how for the Canadian e-referral and e-consult specification, we applied the collaborative standards development lifecycle process. So we started by conducting an environmental scan to find relevant guides. And this one was, a bit of a ringer because we knew that there was already a very well implemented grassroots guide for e-referral in Canada that we wanted to use as a starting point. And so what we wanted to basically say is, well, what's out there internationally here in Canada, and what is the scope of those guides, and what do we see for similarities? And then we went to kind of structure our guide and did some use case analysis, and we were able to basically say, when this gets lifted to become Pan-Canadian, this is the initial scope for the release. We set up environments, right? So we set up our GitHub repository where our authors would be able to kind of collaboratively work together. We set up an implementation guide, space and simplifier that was connected to our GitHub repository so that we had a place that the public could then interact with the content, both the resources and the guide. And then we went about, after kind of initially saying, okay, this is what we're kind of cutting out and lifting from the initial scope of the grassroots e-referral specification, hosting discussions on the public working group for what information should we enhance in the guide, what types of improvements would we want to see. And all of those kind of decisions were made through the working group, as well as the decisions on feedback that came externally, right? So oftentimes we would receive feedback through ballot releases or even through Jira tickets, and the working groups oftentimes many calls of the working groups or to kind of review these discrete feedback items and say, well, let's weigh the pros and cons of making these types of changes. In this case, I think it was actually adding a concept into a value set. And what are the feedback? What is the impact of making that type of addition? So ultimately the ticket was reviewed, right? Triaged. A decision was made, and it gets assigned to the person responsible for actually acting on it. So just kind of like formalization of the process. Lastly, after the change is made, the idea was, because it was a collectively developed specification, I think there were multiple authors involved in actually producing the changes. There was pull requests used in GitHub to actually allow for us to, as a working group, review, okay, the last time we talked about this add RFI issue, it's now been applied. Let's review the content together and socialize the change that's occurred. so that we know effectively that the the thing that we previously have decided on has been actioned against and it's present in the continuous integration build today. So, all of these pieces together like are not complicated to set up, and the process itself is not overly complicated to participate in. And so when you kind of actually peek behind the cover, you can see it's really just folks coming together and wanting to have, tools support a fundamental decision-making process. The last piece is what I think is more one of the more interesting areas, which is after those changes are made, the working group has kind of reviewed them and they've been incorporated into the continuous integration build. Ultimately, at some point in time, those changes get packaged up into a formal release and those get put forward for feedback. So oftentimes, I think for EREC, it went to ballot maybe 3 times. I'm trying to actually remember to basically say, hey, we want formal feedback on this. And then that resets the steps for 2 and 3 that we just talked about. So it works in a cycle, particularly in that feedback refinement cycle for a number of turns. And then eventually, typically yearly, we get to then test implementation guides like the Canadian e-referral at testing events like the Projectathon. So I pulled a picture from the 2025 IHE Projectathon. It was really cool. We hosted it here in, I should say there in Toronto. So it was in person and it was like the perfect proof of like how specifications come together and result in testing. So we had 23 organizations ultimately that came and not just implemented the 5 Pan-Canadian specs, but they actually tested the exchange with partners. And it was used to solicit feedback on, what improvements should be made in the next cycle, but also to help assess the maturity of the guides. Like, are these relatively stable? Are we seeing kind of implementers have relative ease in putting these into their products? So I'm going to give you the really quick flyby of what Pan-Canadian specifications exist in FHIR today, with the intent that basically if you're really jazzed about what I just talked about and having kind of low barrier of entry, these are the places that are available and open for you to participate in today. So there are many different standards that we use in Canada, and they're not all in FHIR. There's some amazing both utilization of things like DICOM and IT. There's some deep implementation of HL73 here. And there are working groups that are Canadian and international that are open and very active communities to participate in. My focus is on FHIR guides because that is, and like interoperability specs because that's the world that I live in. So I'm going to actually talk a little bit about particularly some of those guides that are available in the kind of base, core, and more space. So we already talked a little bit about how bases fit into that overall kind of layering of specifications. The Canadian baseline is our national base specification, which effectively just means it is the place where we convey those realm-specific guidances, this is how we structure telecom. This is how we structure our national provincial identifiers. This is how our provinces are communicated for addresses. Here's some common extensions that we will typically see that are socialized across a very large number of guides. The thing that's really interesting about the baseline, it's actually the baseline was developed through a grassroots working group that started convening about 6-7 years ago, I guess now. And we were convening at a time when there actually weren't a ton of FHIR guides available in Canada. And so what we wanted to do was initially have a starting set of expectations where, effectively we could start to try to promote natural harmonization of practices. And so the idea was, can we try to be one of the first places that folks look at for, what's typically required for some of these core concepts, that if we could have enough kind of ubiquity that we would drive ultimately harmonization over time because effectively those concepts were repeated in other guides. And so it's been a journey for us. Like we started off with, I would say, actually a lot stronger constraints. And as we started reviewing against implementations here in Canada, and we started to kind of understand our identity as a national base and like looked at how other national bases formed, we started to realize that we actually needed to relax back in some of our expectations and make them closer to recommendations. But what was really interesting was even just kind of going through this over the last 7 years and forming into this kind of true national base, we kind of continuously saw that enough people really wanted to ultimately be able to have more prescriptive constraints in place. They were really excited to say, what if we could get a specification that could actually get systems to support this element that was really clinically meaningful? Or what if we could have a specification that would allow for, permutation of this particular snowman value set and consistency and use in this type of terminology? And so we always saw that there was this momentum, and we knew that if enough time passed and enough people continued to feel this way, that next layer down, which is a national core, would eventually come into place. And eventually we got that wish, right? So the Canadian core is ultimately, and I think you guys are probably pretty sure I saw the agenda. You guys have heard about the Pan-Canadian Health Data Content Framework and the CACDI. The CA Core Plus Implementation Guide is effectively the implementation and the interpretation of the content from that standard. So it's the interpretation of the CACDI and to say, here's how you express those rules in FHIR. And the intent is to set the constraints that are expected to be demonstrated across domains, right? So across patient summary and e-referral, care services directory, and a number of other kind of bubbles in the space. And that the core is intended to really serve as, I would say, maybe the default configuration for servers, right? What does everybody have to have out of the box? Because we want it to be this kind of foundation for jurisdictional national health IT implementations. And when I started doing this presentation 2 or 3 years ago, we had just put out a release of core. And since then, it's really cool. It's had substantial development and feedback, and it's had a number of cycles of refinement, and they put out something like 8 releases, and they had one that came out in March that I think is technically still open to feedback as of tomorrow. So so much to say that I think that momentum has really, really ramped up to a lot of interest in this space, and this being, I would say, one of the more recommended areas to participate in that particular working group if you're interested and just getting started with FHIR working groups in Canada. This other spec that I just want to briefly touch on that kind of fits into this overall foundational space is called CAFEX, the Pan-Canadian FHIR Exchange specification. And so if we think about like baseline and core defining rules about data content, right? What does it look like? What is the structure? What elements get populated and when? CAFEX is the rules for how do you exchange that content? How do you ask for it? How do you query? And it separates data content from exchange. And one of the really cool things I think about CAFEX is that it allows for these kind of conditional expectations as well, to allow for it to be flexible for servers that maybe don't support allergy intolerance while others do. And the underlying goal was to kind of raise the floor for default capabilities so that we would have that predictability for applications and ultimately for folks who want to receive data that they could build around that. I'm going to skip over Pan-Canadian patient summary because I think you guys got maybe the debrief yesterday. Pan-Canadian e-referral and e-consult. I touched a little bit on this in my example. The goal is to define, obviously, a standardized way to create, exchange, and to update electronic referrals and consults using FHIR. I think one of the things that's really interesting about this that I just want to touch on is that it's one of our specs that uses the FHIR messaging paradigm, which makes it, I think, really, really interesting because it really focuses it on the workflows for e-referrals, like how do you send an update and respond to a referral, but the workflow has such a inherent impact on the actual values in the resource, like to the point of like fixing those values so that you can create automated processes when your system receives a FHIR message with those details. It's really, really cool. So it's another one I'd recommend you guys look at, if not participate in. CACSD, I'm going to breeze through this one. One of the interesting things about CACSD, it's actually an extension of an existing IHE specification. And so the intent is ultimately to provide rules on how do you access and ultimately structure service directory information. So things for healthcare providers, organization, locations, and services. And then the last Pan-Canadian specification, if you're interested in it, is the Pan-Canadian Shareable Health Links. Like CACSD, it's another example specification that actually extends an international version. Patient summary is the same way. So the goal of the goal of CACHL is to enable patients to actually be able to mediate the exchange of their information. So they can generate shareable links, oftentimes shared with QR codes. And it's one of the exchange methods that we use in patient summary because it gets partnered with obviously a data content spec to combine exchange methodology with data expectations. The cool thing I think about these specs that are maybe at the Canadian level, but they're extending the international standard already, is that by participating in the working groups and helping to kind of put forward refinements for these specs, there is that activity where we're beaming the kind of those changes back to the mothership. So a change that you're recommending in the Canadian space is often then getting also promoted into the international space, which is a really cool thing to be able to say, I've impacted IPS this way. I've impacted SHL because I participated in a working group here at home that ultimately helped refine how this is getting implemented internationally. So I would say, participating in those working groups alone is really, really interesting from that perspective. So that's the flyby of the Pan-Canadian Fire specifications that are available. They are open and public working groups that you can participate in with many different levels of experience and perspectives that really are just looking for enthusiastic folks with differing perspectives to participate in. I wanted to just end this on some of the additional resources that are available out there to help you find the work beyond just Pan-Canadian specifications, the work of others, because I think harmonization, even if you are working in a space outside of the ones that I've mentioned today, is really important. So getting familiar with with the Canadian Fire Registry so that you can find other guides in Canada working in your space, because chances are if you're working in labs in BC, that you will have some commonality to folks that are working in labs in Alberta, in Ontario, and Prince Edward Island. So having a way to quickly find which profiles and implementation guides exist in Canada is really critical. The other one is fire.org/guides/stats. It's just a really, I would say, a more advanced way to search for which international guides surface up which different profiles on various resources. So I really like that as a tool whenever I'm trying to figure out at first who else is out there that's worked in this space. Lloyd also already got to show you chat.fire.org, also called Zulip. It is an incredible, incredible resource. It's an incredible community builder. I cannot recommend it enough. And then the last resource is the extension registry. So much like going and looking at other people's guides, I often will recommend if you think that you need to extend something off of the base fire specification, go to the extension registry first. It's kind of like the area where HL7 has kind of posted its sanctified extensions, where they've said we can't put this in a change into a base resource, but we think if you want to model this content, you should probably model it this way. And so that's where they ultimately register and makes their extensions accessible. That's definitely one for the bookmarks. And I apologize, I wanted to leave 5 minutes and I know I didn't, but are there any questions that folks have?
Thank you so much, Sheridan. That was wonderful. Lots of great information. And I absolutely love your enthusiasm for standards and also the message that it's such a welcoming community and it really is open to anyone. So that's a great message. Thank you.